In this class, we're going to take a look at how you solve quadratic equations by factorising. So quadratic equations can be solved in two ways, either by factorising or by using a numerical method called the quadratic formula. So in this class, we're going to look at factorising. In a subsequent class, we're going to look at the quadratic formula. So we're going to take a look at these four examples, but before we get to those, let's just backtrack a little and think about what is a quadratic equation, what is a quadratic expression, and some of the considerations that we'll bring in to solve these guys. So the first thing is that a quadratic expression, if you've not seen this before, is an expression of the form ax squared plus bx plus c, where b and c can be zero. In other words, this part can disappear. So as long as you've got the x squared term, either just 1x squared or some multiple of x squared, then that is a quadratic expression. Most of them are going to be in trinomial format, so 1, 2, 3 terms, that's a trinomial, like this guy and like this guy. But there are also other variations as well, like this guy, which doesn't have an x squared, which doesn't have an x term, sorry, and this guy, which doesn't have a number term. But in general, this would be your form of a quadratic expression. Taking that expression and setting it equal to 0, like these four here, is turning it into a quadratic equation. So this is your standard quadratic equation. So it's worth remembering that format. That's what your quadratic equations should all look like. It's just a case of what are the a, b, and the c values. So for this guy, the c value is 12, the b value is 7, and as is commonly the case, the a value is 1. The question is, how do we solve these equations? So they're not like linear equations. Linear equations, for example, 3x minus 1 equals 11. We solve these by separating the variable, the x, to one side and putting the numbers to the other. So we would leave the 3x on that side. I'm assuming you've already seen these linear equations if you're now doing quadratics. We move the minus 1 to the other side to make a 12. We then divide both sides by 3 and we get x equals 4. So there's a very definite process we go through there. Separation of the variables, x's to one side, numbers to the other, and then dividing at the end. Quadratic equations we do not solve like that, and that's one of the big challenges to get your mind adjusted to using a different method for solving equations. We solve these guys instead by factorising. So we're going to factorise these expressions, and depending on the format of the expression, that will determine how we go about factorising it. So there's basically three possibilities. You could factorise it as a trinomial if it is in trinomial format, which means that you're going to rewrite the expression in two brackets like this. So it would be probably an x and an x, although there could be numbers here as well, and it'll be plus or minus some number value there and plus or minus some number value there. So don't worry too much about like whether it's plus or minus. We'll deal with that in the actual examples, but that would be roughly the format. A second option is to factorise using a common factor. Common factor is usually going to be x, and that would be something roughly like this. These are not precise because it could be a number here potentially, but roughly it's going to be a common factor factorising. And finally, you can factorise these as a difference of squares. So that would be x plus or minus p, and then x plus, it would be x, say minus p, and then x plus p. Let me just tidy that up a little. So a difference of squares factorises in a very particular way. So those are your three options, either factorising as a trinomial, either factorising as a common factor, and factorising finally as a difference of squares. So we'll see these options here. For example, this one's going to be a difference of squares, these two are trinomials, and this one's a common factor. So that is really the challenge with quadratic equations. It's not so much solving them as it is getting them factorised. Once you can learn how to do the factorising, then these equations themselves actually become quite easy. If you've got experience in this, great. I'm not going to talk too much in this class about the factorising. I'm going to assume you already know how to factorise. The more experience you've got in this, the better. If you're not sure about these types of factorising, if when I go through these examples, you're not sure what I'm doing, check those out in another class. There are classes on each of these three types, because that is the key to solving these equations. Learning how to factorise effectively, once you factorise, as you'll see in a moment, solving an equation is actually quite easy. So that's the theory. Let's see if we can apply it to solving these guys. So let's start with the first one, which is your kind of standard trinomial. This is probably the one you're going to see most often. So we want to start by factorising the trinomial, which we're going to do into two brackets. How you go about factorising is kind of up to you. There's a few different methods you can use, but this one would factorise with an x and an x, a 4 and a 3, because you need 4 times 3 to make 12, and you need 4 plus 3 to make the 7 in the middle. Once you've got it factorised, all we do at this point is split them off, split the factors off into two equations. So you get x plus 4 equals 0, and you get x plus 3 equals 0. So you're just basically forming two equations by taking the bracket, setting it to 0, and taking the other bracket and setting it to 0. Then you've just basically turned these into very trivial linear equations. So moving the 4 to the other side, separating out the terms would give you x equals minus 4. Separating the terms over here would give you x equals minus 3. So this tells us that when you're using the trinomial method of factorising, you're going to get two solutions, okay? Quadratic equations can have up to two solutions. Sometimes they've only got one solution, sometimes they don't have any solutions. So it's either 0, 1, or 2 solutions. And we'll talk more about those number of solutions in a subsequent class. But for this trinomial, we've got two solutions, minus 4 and minus 3. That means that these numbers independently would satisfy the original equation. So for example, if I take the minus 3 and put it back into the original equation, minus 3 squared is 9. Minus 3 times 7 is minus 21, plus 12, add those together, and we do in fact get 0. So that validates that that is a solution, and we could do the same with the minus 4. Okay, cool, right, so that's the idea. Let's take a look at the next example, fairly similar, just got a minus here, but that doesn't really change things hugely, it just makes the factorising a little different. So setting up in the two brackets, we would need an x and an x. To make a 15, it has to be a 5 and a 3. We want to make a plus 2, so it would have to be plus 5 minus 3, and plus 5 times minus 3 does give you minus 15. So that's factorised nicely. Splitting off into two equations, x plus 5 equals 0, x minus 3 equals 0. Just going ahead to solve those kind of trivial equations, x equals minus 5. That's our first solution, and then x equals 3 is our second solution. So you can see that really from this point forward, from here forward, it's quite an easy process. The difficulty is getting the factorising done in the first place. Notice also that you probably don't really need this line of working. I mean, it's fine to put it in there, but basically what always happens with these is that if you've got an x plus 5, the solution will be minus 5. If it's an x minus 3, it'll be plus 3. In other words, you always just get the opposite sign. That's because we're taking this, setting it to 0, and then moving the number to the other side, changing the sign from plus to minus or minus to plus. At first though, as you're starting out with these, I would recommend writing in that line of working, just to get used to splitting off your two brackets into two equations and then taking the process forward from there. So those were both trinomial type factorising, so that was the first type here. So taking a look at the next one, which is a difference of two squares. If you're not sure about a difference of two squares, then check out the class on that and then come back in, or just follow along here and then check that out later on. So this one factorises also into two brackets. So this one would need an x and an x, a 4 and a 4. Keep this equal to 0, and these factorise with 1 plus and 1 minus. Doesn't matter if you go plus minus or minus plus, but it needs to be one of each. So that's basically this format here, so the difference of squares format. Splitting them off into two equations, just in the same way, we get x plus 4 equals 0, and we get x minus 4 equals 0. The way that these guys work, because your two brackets will always have the same number, but with a different sign, you're going to end up with the same number as the solutions with a different sign. So this one will turn into an x equals minus 4 solution. This one is an x equals 4. That's always going to be the case with a difference of squares, because when you factorise them, they have to always factorise with the same number. here and here, and a different sign, 1 plus and 1 minus. So if you see one of these and you end up somehow with two different numbers, then check your working because something's gone wrong. Okay, so that's another type, difference of squares. They're probably, I would say, less common, but definitely be aware of them. You will see some of those. The final type here is not a trinomial and it's not a difference of squares, so it has to be the other format, which is a common factor type factorising. So the common factor between those two terms is an x. So we pull an x in front of our bracket. Remember to keep it equal to 0 when you factorise. So x times x to give you an x squared, x times positive 3 to give you a 3x. This one looks a little different because these guys both had two brackets. This time we've only got one bracket. But what we basically do here is we keep the bracket equal to 0. So x plus 3 equals 0, just like we did with these guys, splitting that off into an equation. The second equation is just x equals 0. So that one's already solved with a solution of 0. So x equals 0. Nothing to do with this one, it's already got that final solution. The other one we just make into x equals minus 3. So notice that with these ones, where you're pulling out a common factor, because that common factor is always going to be on its own in front of the bracket, you're always then going to turn that into an equation where it's like that letter common factor equals 0. So that means you'll always get a 0 solution for these. So therefore, notice that there's a few differences between these types of factorising in terms of the solutions they give you. So a common factor will give you a 0 and some other number. The difference of squares will give you two numbers that are the same with a different sign. And the trinomials can give you a variation. So with these guys, you're going to get different numbers, or potentially even the same number. If your brackets were the same, if you had, say, x plus 5, that's not a difference of squares, kind of looks like it, but they're both the same sign, then the solution for this guy here would be x equals minus 5 and x equals minus 5. So you get two solutions, but you only get one unique solution. So we'd say that this equation's only actually got one solution, one unique solution. So that's another variation that you might see. So there's quite a lot going on in these in terms of the variety of question types. The main thing really is the factorising. The big mistake that I see students make in these is not the end part. The end part pretty much everyone gets right all the time. It's not really recognising what to do once you've got it factorised. It's really just getting to the point of getting the factorising correct. These tend to be okay, the trinomials. These are less popular, so you generally get less practice on them. That means that when you do see one of those other types, you can just forget about it and you're like, how do I factorise this? How do I factorise this? So when you're working some practice questions, which I would really recommend working quite a few of, try to make sure that you hit up like a variety of question types. That's just going to give you more chance of getting these correct when you see them on a test or an exam or something like that. So make sure that everything I've said there makes sense. There's quite a lot to take in, and once you're confident that it does make sense, then try quite a few practice questions on this topic.